Okay, so dear students, today I'll discuss frictional force in slipping motion. Already in my one of the video I've discussed how to find frictional force in rolling motion, that is when the object is not in slipping, right? So today I'll discuss if the object is not in pure rolling motion in rotational dynamics, then how one can find the direction of frictional force and magnitude of frictional force. So today I'll discuss frictional force. So frictional force in slipping motion in rotational dynamics, right? So object is not in periodic motion, right? So it is slipping at the point of contact. Then how one can find the direction and magnitude of frictional force? So in this case, so first let us understand, already I have discussed all these things earlier, videos are there. The velocity of center of mass, this is VCM, is there, or at the point of contact. So this is the point of contact. So at this point of contact, so velocity of point of contact is not equal to velocity of the surface. Then this is known as slipping at the point of contact. This is the meaning of slipping is there. So first, in this case, as far as direction is concerned, it always opposes the direction of slipping is there. See, object is in pure rolling motion, then there is no slipping at the point of contact, there is no relative velocity at the point of contact. If it is in slipping, then the velocity of contact of the object is not equal to velocity of the surface is there. Then it can move either in the forward direction or in the backward direction is there. So always frictional force opposes the direction of slipping is there. Means if it slips in the forward direction, the direction of frictional force is in the backward direction, or if it is slipping in the backward direction, the direction of frictional force will be in the forward direction. So in this case, the direction of frictional force opposes the direction of slipping. So it opposes. For example, suppose this is there, this is the BCM, and this is omega, and suppose this is at rest, and omega is, if omega is VCM by 2r, then first, if this is there, the velocity of the point of contact is equal to VCM minus omega r. So this is VCM minus omega is VCM by 2r into r, So this is VCM by 2. So resultant velocity in the forward direction. So the resultant velocity. So the resultant velocity is in the forward direction. In the forward direction. Hence, slipping is also in the forward direction. Forward direction means this point is moving in the forward direction, right? So this is forward direction. So this is the forward slipping. So the frictional force would be in this direction. So therefore, the direction of frictional force is in the backward direction. Is in the backward direction. In the backward direction, right? Already I told you, in periodic motion, the velocity of the point of contact always matches with the velocity of surface. But when the object is slipping, then it is not equal to that. So either it will slip in the forward direction or backward direction. In this specific example, the resultant velocity in the forward direction. So slipping is in the forward direction. So direction of frictional force is in the backward direction. Right? Now, what is the magnitude of this frictional force? So see, if the object is slipping, then the frictional force always takes its maximum value. Right? So if an object be in slipping on a surface, then Fr is always taking Fr max, that is mu times of n. That is mu times of n. Therefore, in this case, suppose its mass is m, right? So in this case, Fr max mu times of n. So this is mu times of mg, right? So this means frictional force is there. Suppose you have given, if you have given at t is equal to 0 v naught, at t is equal to 0, then at any time its velocity can be written as v is equal to v naught minus mu gt. So velocity keep on decreasing, and you can write also omega is there. So initially there is no omega is there. So at t is equal to 0, omega is 0, right? So you can type find first torque. So this is mu gm into r, and suppose if it is a cylinder, obviously solid cylinder, then this is equal to I alpha mr square by 2 into alpha is there. So m gets cancelled, 1 r gets cancelled. So you can get the value of 2 mu g by r. So alpha is equal to 2 mu g by r. So omega is equal to alpha t. So this is equal to 2 mu g by r into t. This is your omega at any time. Right? So we can find out omega, we can find out linear velocity at any time t. Also we can draw its graph in this case, right? So for different cases you'll have different solutions are there. So in this case we can draw the graph, right? And object finally it will be in parallel motion after some time. It will never stop, right? So initially it is slipping. After some time the object will come in the for parallel motion is there. Okay. So one can draw its velocity very easily. This is the linear equation at this point. So we can draw its graph very easy. So V versus T, graph will be linearly. So it will become, and then after this it will be initial velocity is V naught. Then this is the velocity, and then you can draw omega versus T, and then it will be in parallel motion, right? So its omega should be, so this is the omega dashed in pure rolling motion, or this is the velocity V dashed, velocity in pure rolling motion. So see, let me summarize here. So whenever you have frictional force, you want to find out in rotational dynamics, classify case 1. The object is in pure rolling motion, then never apply Fr is equal to mu times of n. Case 2, if object is slipping, then for direction, it always opposes the direction of slipping. If it is forward slipping, then it will be the backward direction, or if it is backward slipping, then it is the forward direction. Frictional force always takes its maximum values there. So Fr is always mu times of n in slipping motion. And since if you divide the force by mass, you will get acceleration, and then torque is equal to I alpha, you get also angular acceleration is there, and hence you can find out the fundamental velocity and omega. Okay, students, in the next discussion I'll give some more about the frictional force. Thank you.